Welcome to Semiconductor Pro in 3 minutes. Today's topic, HBM, or High Bandwidth Memory. Let's break it down.
Right now, every tech company in the world is desperate to get their hands on high-performance GPUs. But did you know, to unlock that GPU's full potential, there's an absolutely essential partner that always has to be right beside it?
And that partner is today's topic, HBM, or High Bandwidth Memory. Why can't ChatGPT run without it? How is it different from regular memory? Let's get into it.
HBM stands for High Bandwidth Memory. In simple terms, it's memory with extremely wide pathways for data to flow through, all at once. DDR5 memory in your PC sits as sticks, plugged in some distance away from the CPU. HBM is completely different. It sits right next to the GPU chip, stacked vertically, like a tall building reaching skyward.
Its biggest strength is the sheer volume of data it can move at once. If regular memory is cars racing down a narrow alley, HBM is a 100-lane superhighway with no traffic in sight.
So how can it move so much data?
The secret lies in a technology called TSV, through silicon via.
Memory chips are stacked on top of each other, and thousands of tiny wires run vertically straight through them. The result is compact, yet packed with vastly more connection points than any traditional memory could offer.
Today's generative AI models have hundreds of billions of parameters. To process all of that, you have to keep feeding data fast enough that the GPU never sits idle, not even for a moment.
Without HBM, even monster GPUs like the H100 or B200 are just wasted potential, silicon sitting idle. That's exactly why the global HBM supply war is heating up right now.
Quick recap. HBM is super-fast memory built by stacking chips vertically. Its overwhelming bandwidth eliminates data traffic jams. And for AI to keep evolving, this memory matters just as much as the GPU itself.
And here's today's pro tip. Because HBM has to be stacked vertically, each die has to be incredibly thin. That makes manufacturing dramatically harder. Picture this, 50 microns, thinner than a sheet of paper, stacked up and connected with tiny bumps. It's almost beyond imagination.
That's all for today's HBM episode of Semiconductor Pro in 3 minutes. If you found this video interesting, please like, subscribe, and I'll see you next time.